Hello, everyone. As you can see from the title of the talk, it's about extending IntelliJ IDEs at runtime. And I would like to clarify a bit what I really mean by this. So in terms of extending, like pretty much every browser now supports DevTools. You can open it, type some code, like console, just log something, right? And then you evaluate this code, and it runs inside the browser. Like you cannot really do many useful things in the browser, but in theory, you could write any extensions for the browser. Maybe there are some extensions for browsers to write extensions at runtime. I'm not aware of them. But there is an obvious question, like, why cannot we do the same in IDEs? Especially IDEs are they're editors for power users. So that should be like a reasonable feature to have. And that's what I mean by runtime. So they just type code, it runs. And by IntelliJ IDEs, I literally mean all of these IDEs which are based on the IntelliJ platform. So there are a few ways you can do it. And like they mentioned on JetBrains platform plugin SDK page, so it's like ID scripting console, Flora plugin, and LivePlugin. So I'll talk about LivePlugin because I wrote it and been maintaining it for quite a few years. There is also like a vague definition of what plugin is, but maybe I'll show it in a second. So here is LivePlugin on the marketplace, so you can basically just install it and it should work. As a caveat, I think Android Studio is really kind of behind the IntelliJ in terms of the code base, so you might get an older version. So there is an obvious question of why. I kind of mentioned it, but as a quick summary, it's like minimal setup. You don't need to create a different project. Basically, like if you want to compare this to standard plugin development route, just try some blog post which shows you how to set up a project from scratch. So you see it's minimum setup, fast feedback loop. You just run code like in developer console in a browser. And as an attempt to have a simplified API for IDE, because it's like, naturally it's quite big code base IntelliJ. So this is pretty much it. And most of the talk will be a kind of demos. And I'll use IntelliJ and Kotlin. And a good starting point might be to have a hello world. So I switched to IntelliJ, it's just in presentation mode. And as you can see, this project is just Gilded Rose code cutter. It doesn't have to do anything with plugin development. So obviously I have LivePlugin installed, so what I can do, I can open a panel called plugins, and I can see plugins there. Basically, each of them is a folder, and inside the folder, if you have plugin.kts file, that's the entry point. So I have this file open, and what I can do, I can type here LivePlugin, which is just the name of a package, and I can say show and do hello, and then let's say use an emoji because that's cool. So if I run it now, you can see there is a notification at the bottom. So this is literally like a normal notification ID, so I can go to notifications and you can see it was there, I can clear them and so on. So this is like a real thing. So obviously this is just a function, so I can do an import. And as you can see at this point that you have all the ID support, you have auto-completion. I can also navigate, if I like control-click or press a shortcut, I can navigate to source codes of LivePlugin. So what's happening here, the package is LivePlugin. So this is a function defined in LivePlugin, which just wraps API of IntelliJ to make this feature of showing notification a bit easier. So that's what I mean, it's like why it's similar to the browser experience, because I can like run this code, it prints something else. So how I've been running it basically is by, so if I stop this, so one way to run it is to press this button in the tool window, just run it, and then you can rerun it, it keeps showing it. And you can also see this file if you like navigate to select project and project view. They're also available under scratches and console, so you can basically see that it's just there and it's just a file on your file system. There are a few things available in the context here. So if I do this dot, you can see there is, for example, project, and project it also auto-completes to name. So we can, if we kind of navigate to this, we can see this is the context of the plugin. And project here, if I navigate to project, you can see this class comes from IntelliJ API. So there is like a layer of LivePlugin which kind of hides some of these things in a thin layer. And then you basically using just normal IntelliJ API. So what we can do here, we can just, for example, say instead of this hello, we can say hello from and paste project name. So if I run this now, it prints from Gilded Rose, which is the name of the project in IDE. So basically, we have access to everything. Also, just to show that, like, we can also have plugin path here, so we can see where the plugin is. So it's like that's how you can figure out where your files are. So that's kind of the basics, right? So it's kind of hello world. Maybe one other thing worth mentioning in terms of like life cycle of plugins. So I ran this code multiple times, and if you make some changes in IDE, it might be useful to kind of clean up after yourself. And for this reason, there is a plugin disposable object. And it's an object which is, you can register a callback here, and it's kind of disposed. So what is happening, so if I run it now, it says, prints the whole path. But now if I go here and press unload, then it calls dispose. So it's like constructor-destructor type of thing. But if I evaluate it multiple times, it kind of disposes the old one, run the code again, and so on. And this disposable, it's an interface from IntelliJ API. It's used in other APIs to clean up after, like, you registered some listener, you want to clean it up later. So that's the idea. That's why there is this button to stop, and there is this button to rerun. So it's like stops and runs it again. And in terms of sharing plugins, like there are a few options. One option is to have project-specific plugins, so you can go and create directory. And there is an option to create LivePlugin, and here you can create directory foo, create plugin KTS, and whenever you open the project, this code will run. That's like one way to share some plugin with your team. For example, the other option is to basically check this setting, and all plugins in here will just run whenever you open IDE. That's another option. Or the final option, which is to create a proper plugin. So I can create Kotlin plugin zip. It creates a bunch of things. So that's like a proper plugin in IntelliJ. Basically, it has to have plugin.xml. You cannot escape XML. And then you can edit this XML, and if you run it, it packages into zip, which you can upload to Marketplace. So that this way, it will be like officially plugin on Marketplace. Or you can just like share the zip file and install plugins from zip file. So these are like the basics of Hello World. So as a summary, it runs in any project, gets syntax highlighted, and like, you know, well, if you get any errors, it will show it. Then there are a few implicit variables in the context of the project, and you can share plugins, basically. So this is a demo. Maybe it's worth mentioning now how it all works quickly. So obviously, there is a Kotlin compiler, and there is JVM in which IDE runs. So there's a source code file, and source code file compiles into class file. Then there is a plugin class loader. Each time you evaluate this screen on the text, there is a new class loader, which loads the class from class file. And then IDE can create like reference to this class, and it plugs into, like, let's say, the menus. We'll see it in a second. And, well, that's the basic of it, right? But then it's like a bit more complicated, because there is obviously, you need a JDK, you need IDE jar files. How does it work? Well, IntelliJ, like while you're evaluating code, it already runs in JDK, right, Jerry. And it already has jar files somewhere installed. So that's what Kotlin compiler is using. And then IDE itself, it should know as well about JDK and everything. It's done by a hierarchy of class loaders. So there are like parent class loaders inside IDE, and they also refer to the same libraries. So why it's all important is because when IDE, like, let's say, forgets through disposable, like, erases all the references to the newly loaded classes, then plugin class loader and classes, they should, in theory, become garbage collectible, and all of this is collected, so you don't kind of use up all the memory on IDE, and then they just disappear. And then you can, again, like, you modify source code, it creates another binary, it's all loaded and plugged into IDE. So that's how it all works. And as an overview, that's why there's dispose and plugin disposable. It's basically, there is a external compiler for Kotlin, which creates new classes. They're not recompiled if you don't change source code. And then just LivePlugin just loads it runs this code, literally, which you have on the screen. So that's an overview. And this is kind of it. This is like the gist of it is that you can have experience similar to what you type in developer console in browsers, and you can also have like environment which cleans up for you what you just evaluated, and that's the big idea. The rest is just like demo of how exactly it works, and I think instead of like doing lots of slides, I did it this way because I think it's easier to understand by example. So like the first thing I would show is just notifications. We've seen bits of it. It was just show function, which kind of wraps IntelliJ functions. It also has a title. So maybe you can say droidcon BLN. Maybe it should be lowercase. It sounds cooler. It's lowercase. So yeah, obviously it has a title. The problem with this is that if you have a long message, it will not look nice. So if I do an exception and do stack trace to string and run this, it kind of looks a bit hard to understand. So this is not a nice way to log things, so that's why there is a thing. What I do is I do this, show in console, which is a function which just like shows it in a run console. So if I do this, run it. So you see, it's the same content, but it's kind of clickable. It's a proper stack trace. Or if it's just like a large output. So what I'm saying, by default, I'll use show function, which shows notification. If it's large output, I do this. Or if you have lots of output, the funny thing, you can just do println. So if I run println, it's just normal Kotlin function. And I can go to console of IDE, and, well, somewhere here, I cannot easily change fonts. So you see it runs to std out and ends up in the log file of the whole IDE. So you can go to help, show login finder, or something like that. There is a logger as well, but I guess what's the point? You know, the println is simpler. Also, like all these things, they exist because you cannot like really debug JVM from inside JVM. So it's like debugging tools. Also, is an idea just to show what could be possible. It's like unfinished thing. There is a function called inspect, and it's a bit like some interactive environments, like, you know, literally what's happening, like you're running code in the JVM and you have access to all objects. It's like a graph of objects. So you could, in theory, like what this is doing, just go in reflectively through all the fields of the project object. And in theory, you could do it with any object. And, you know, also click on a button in the user interface, find the object, follow references to any other object at runtime. And yeah, so that's like another idea of how things could have been done. And obviously, just to show more UI things, you can just call functions from IntelliJ API. So here, this is not LivePlugin at all. It's just like a function from OpenAPI, and it just shows a dialog. Or similar thing with user input. So here, if I run this and it inserts something. So this is like a function. I'll show input dialog, takes lots of parameters, and returns user input, which is then shown. So these are all the ways to show notifications, really. So switching back to this. So this is what I showed. Show, I would use show by default, show in console for large output, and println if you have lots of output. For example, if you write in inspection, that maybe println is a bit better. So these were notifications. Now it's like the big part with actions and action groups. Action inside IntelliJ is pretty much, I would describe it, and it's not official definition, but I would describe it, it's a stateless function. It's a stateless function which takes like a context of the IDE as an input, and it modifies the state of the IDE. And actions is pretty much anything, like if you open the menu. Menus are actions, all the things you like call from the menus, they're all actions. Normally, with plugins, you would define them in a plugin XML. So here, like with LivePlugin, I defined this function, register action, just to do it from Kotlin. And to demo it, I'll use this function called, use the action called show project name. So essentially, this is like register action means there will be an action, and it takes an event, which is the context of the project, the context of where it's called. So you can show specify type explicitly. So here, an action event, you can see import comes from IntelliJ API. Oh, you cannot see, the top is a bit cut off. Nice. So yeah, it comes from IntelliJ API, so it's not part of LivePlugin, right? So if I run this now, I can go to, let's say, help, find action, and I type show project name. And so the action appears there. So it's like a real action, it's integrated everywhere. So if I run it, it just prints gilded rows, which is the name of the project, as we've seen. So we can do like other things here. So that was ID ID of this action. So we can also have a keystroke. So let's say call it Control-Shift, let's say dot. So I can now press Control-Shift dot, it prints it. Right. Then another thing you can do, you can have an actions, they can live inside groups, and this is an ID of an action of another action, and menus are also actions. So if I do tools menu, it appears magically at the bottom of tools menu. If I call it, it works. And the good thing here is that actually it's all unloadable. So if I press this top button, it unloads it, and it just disappears from the menu here. So that's pretty cool. The reason it works is because register action is defined as an extension function on the context of LivePlugin script. Maybe this part of API is a bit too complicated, but basically it's just passing in the plugin disposable thing in. There is a way to pass plugin disposable explicitly, so we can do it like this, basically. But it's just a bit more succinct doing it like that. So, yes, there are also other menus. So you can go to source code of LivePlugin, and the problem, there are other menus and they have their own IDs, but the problem is like it's kind of hard to find them. What I did, I just searched for, I looked at the source code of IntelliJ, and I put some of them into these constants, so just to show another one because it looks kind of fun. Editor pop-up menu, so now it's the bottom of the editor. So yeah, you can figure out yourself what's there. And this is just LivePlugin things, but actually there is a class called an action, so show project. I'll refactor this code to use more of IntelliJ API. So there is a class called an action, and to create an action, you have to extend it. So that's the actual definition. Like anything that inherits from an action class is an action itself. And it has one abstract function, which is basically what we have here. So I'm just copying code into there. So that's like a class now. And instead of passing callback, I'll delete this code and I'll specify it like this. So basically refactoring. Yeah, and it still works in the same way. Well, now we can add more things, like we can have an icon here and so on. Yeah, I'll make action disabled, for example, in the menu and so on. So these are the basics. Oh, yeah, obviously action groups. I'll show it in a second. So these are the actions, and for action groups, it's a similar story, but there is a class called action group, and everything that inherits from it becomes an action group, which is like a bundle of actions, really. So here I have like a demo. I won't type everything from scratch, but if I evaluate this code, maybe I'll unload this first. So if I evaluate this, this creates this pop-up menu. So one thing we can do is to open links in a browser. It's just part of IntelliJ API. So it's like LivePlugin on internet, on GitHub. Another thing would be to, for example, run a script. So if I run this, you see there is a background process happening. So what is going on is that, well, actually it runs a shell script. By the way, it happens to be in this folder, and there is hello sh, that's what it's running. So hello sh, it runs hello, and then, it runs a script, like shell script from a string here, and it does sleep 5, which means sleep for 5 seconds. And actions, the actions they executed on UI thread, so you shouldn't do any long-running things or like anything slow. And this is exactly what it is. So it's like sleeps for 5 seconds, it will freeze the whole user interface. That's why you kind of have to do it via run background task function. So just mentioning it that there is a way to run something in the background without freezing UI and so on. So it runs it in the background. It also picks up this hello sh, which is how plugin path is used. So yeah, that's the background task example, that you can have background things. Another example would be to, let's say, make an HTTP request. So if I do HTTP request, basically loads the home page from DuckDuckGo and shows it here. These notifications, they render bits of HTML, funny enough. And here, the interesting thing is that I'm using HTTP4K library, which integrates with a KHTTP. But the interesting thing is that LivePlugin picks up all these jar files from the same folder, and this is done by this instruction, like add to class path. So it can have external jars as well. And finally, another idea is like if I close all of this, like how do I edit a menu? Well, actually the idea is just open the source code for the menu and just modify it there. And here, like the way it works is like I'm defining action group and then I'm registering it in the tools menu. And I'm having like this shortcut which shows me a pop-up in these two lines. So the interesting thing is that it's also in the tools menu, and that's what I meant that it's like an action group which shows as a submenu. That's what it is really. All of these are action groups, all the submenus. So that's like a demo of actions and action groups. So everything, pretty much every time you type something, move the cursor, these are actions. It's like a stateless function. They can be registered, unregistered, and action groups are also actions. These are the takeaways. And it's basically like the most useful thing to do because you can integrate any scripts and anything else by actions. But it would be nice to do something a bit more, I know, related to the code. And that's why, well, let me collapse this. And that's why it might be nice to be able to modify text editor. And as I mentioned, because everything is an action, to do some modification in text editor, we should register an action. And I'll call it random case, because it will be an action which will, like there is upper lower case actions, but this will just randomize it, just to have a random thing. Well, actually, even before that, the other thing, the way I would start doing it is like you can get a project and then there is a current editor variable, and the current editor is just a class from IntelliJ API. And you, for example, have a caret model there, and you can say, move caret to offset, move to offset, and that's just an int. And an offset, it means in the current editor content is represented as a string, and you just go to the index in this string. So if I run this now, you can see the cursor jumped to the top, or if I do, let's say, 100, it will jump to 100. So it's a bit more interactive. Instead of like registering action, then call in shortcut, you can just run code straight away. Or the other example, just to have something visual quickly. So you can have selection model, and you can set selection, I think, from 0 to, let's say, 200. Let's just run it, it does selection. So this way you can like really quickly experiment with API. So if you just want to see how API actually works, because it might not be always obvious, so you can just try this. So here, maybe just to save time, I'll cheat and just copy things. So the idea here is to, from event, we can get document. It should get document. Okay. And we should get an editor, yeah. And then they might be null, so it's worth kind of copying this. So we're checking the document and offset are not null. Because, like, you know, we might call the action when all editors are closed within some menu. That's why it's all nullable. And then we want to have basically so text before and after. Maybe at this point I would even like show something. If I was like typing it for the first time, I would definitely try it before typing too much code. So if I run this now, we should have, we need to register shortcuts, keystroke, and I'll do the same, control, shift, dot. So if I run this, it should print the current word. So yeah, it does print offset, control, or set selection. So it seems to work. I would always check for edge cases as well, like, you know, go to the end file. But it seems all right, because I just copy-pasted, I guess. And then we want to randomize this text, so it will be just text. So what we're doing to get the text, to be clear, so we have offset, and we can get the text of the current document, drop everything to the current offset, and then we take code while it's letter or digit, and similar thing with taking text in the current word before the caret. We kind of take everything to the current offset and go back, picking everything which is letter or digit. So it's like, it's not a proper implementation, of course. So here maybe use random from Kotlin. And here we just then concatenating these two and mapping them randomly to upper or lowercase and join back to string. So this should be text. Right. And then what we want to is kind of, we can want to modify it. So the reasonable thing would be to try this and say, replace in the current document text of the beginning of the world, the end, and the new text. So we can try this. And if I run it, kind of blows up. And the reason, to be fair, this is like a quite descriptive error. It says write access only allowed inside write action only. So this is a bit confusing if you have a look in IntelliJ API. There is the concept of write actions and action. So this write action is not action in a sense like I was just describing. It's like something else. We could do that, but then it will complain about something else because it has to be like undoable command. So overall, it's like this kind of thing will work. Just to finish this thing, this will work, like execute command. Oh, need to import. So this will work, and if I call it now, so it like does it random case, and I can undo things. So this is like a bit confusing, but I think it's worth knowing that these are the actual threading rules for all IntelliJ plugins. And there is a better way to do editor actions, I'll show in a sec, but these are the rules. So if you are on UI thread, you can read anything without any additional effort. And if you want to modify something, you need like modify state of an IDE in general. You need to wrap this code into write action. And that's like UI thread. And from other threads, you cannot modify things. You have to kind of schedule for modifications to happen on UI thread. And if you want to read, you need to have read action. So these are the rules. And this is why it wasn't working. But luckily, it's already inside IntelliJ API, there is this thing called editor action. It just takes different parameters here. So it's like editor, caret, something else. So we could go from editor. So it's like slightly different thing, but then we won't need, it's like less nullable. This is not null, this is not null. Think offset is not null. Don't need this. And it will still work. That's kind of, and then you don't need to think about all the threading. So it just works. So yeah, these are text editor things. And obviously you can do everything else. Everything you can see like folding, highlighting, you can do via this API. Also maybe as to give an idea what you can do in terms of real world usage. And I forgot to mention with actions. So it's like, it was all kind of fine with actions, but can you do anything like useful? So one example I have is like, it's a Kotlin project. There is no Java code anywhere, and it's a real thing, like on the project I'm working on, there is no Java anywhere, there are no plans, but Java is still the top line in this menu. And like, turns out this menu in particular is not editable. So lots of menus in IntelliJ are actually editable. You can go find them in settings, but not this one. And well, there is a U track for this. Like when it's going to be fixed, I don't know. So what you can do, just do this. It's a little bit tricky, I guess. So you can find action by its ID. And so this action at the top, maybe I'll reformat it. So action at the top is finding as action group. This is the action group for new elements. And then we can find action for creating new Kotlin files. So this whole menu is new element action group. And the second row is new Kotlin file action. So what we're doing here is like trying to reorder them. And the simplest way I found of doing it is to remove Kotlin and then edit, but with this constraint first. So if I run this now, it literally becomes the top one. So yeah, problem solved. Yeah, slightly more complicated example related to the editor is collapsing things in Kotlin. I think it was here. Yeah, so like one example, like it doesn't matter what this code does, right? There is item, which is a data class. So I can, when the definition of the item, multi-line, right? I can collapse and expand it here, but when I create item, it's like it doesn't collapse. There is no fold-in region, and it like collapses the whole array. It's like, why? Well, just because they didn't implement this feature. Like, I don't know how prioritization works. So it's a bit more complicated, to be fair. And you can do it like I showed in editor, like directly create a fold-in region, this offset to that offset. It will be very kind of, one-off. But there is turns out that, like, I looked at the source code, I copied this, this code called Kotlin fold-in builder, and then I modified it. I can show in details, but like, maybe I'll expand it a bit. So it's basically all about, there are maybe a better way to look at it. Is that like there are only 3 functions which override everything else private, right? So this is false, ignore that. Build language for regions, what does that do? It kind of appends descriptors, it does something here, oh well, maybe it's too much to show. I guess the whole thing was like needs folding. It looks at syntax tree inside and I think one of these was missing for some reason, and then it just shows the range to fold, and I think it was value parameter list. So all you do here, you go through syntax tree and return a text range, and then it will call this get range placeholder text, and it does this. Well, maybe just for fun, to show that it's real, I'll reevaluate it. So if I go back now to the code, it should be foldable, and it folds with exclamation marks. So this way, you can just plug into existing classes which extend Kotlin plugin, and you can like add folding regions where they were not supported. So that's an example of editor things. So that was it about the editors and with some extras. So as a takeaway, so for editor, for text editing, there is editor and document classes. You can do like everything you can imagine, modify text, do highlighting. There are some threading rules, so you should be careful about that, and all the undoable commands. And text editor is a bit like, it is very useful. It's like that's the basic point where you can just start doing something genuinely useful, but a bit more advanced topic of actually modifying code, or like looking at it after it's been transformed into a syntax tree from text. And this is where intentions and inspections come into play. So here, it didn't load. So here, I don't know if you know, maybe it's not obvious, the difference between intentions and inspections. So I'll start with intention, it will be a bit more clear. So I'll expand code bit by bit. Also to be clear, the only function here, which is like part of LivePlugin, is this function, which kind of wraps API a little bit, but the rest is just like normal Kotlin Java code, which is used for writing plugins. It's just like a bit easier experience writing it. So in intention, there is like first question, is it available? Intention is this thing that happens. You press Alt-Enter, you see the list, these are intentions. So the first question is like, is it available? And the way it works, it looks at the current element, which is PSI element, which is abstract syntax tree. And then, oh, nice errors. And then it checks if its parent is of this type, and then it checks that text contains OMG. So to give a quick example, if there is something like println, and obviously this is a silly example, if I do OMG, and oh, I don't have it, I need to run this code first. If I do OMG now, it has this action replaced with cat. So if I do it, it does replace it with the cat. And so there is obviously a question like, well, how did you know how to type all these things? And the simplest answer is that, I don't, but I know how to find, so there are like different tools. I use this one, although it doesn't work that well lately. Basically, you can install this PSI viewer plugin, and then you navigate to code, and it shows you the tree, syntax tree of the whole file. And then you can go here, and usually at the bottom here, it shows you the class names and everything else you need, and then based on that, you can just experiment and figure out what to type here. And that's pretty much it. So here, the first function is available. So if I print Alt-Enter here, there is no cat, but if I do here, there is a cat, because it's also it understands its own code. So then the question, how do you replace it? So you get the text of the current element. Obviously, you just replace on the string. That's going to be a string of type string, and then then we want to replace current element, but we're replacing object with object. We cannot replace this syntax tree node with the text, so we need to convert new text into object, and that's how it can be done via some API of IntelliJ. You can copy it from existing intentions. That's the usual path. So this is the intention, and then there is a similar thing with inspections, which is good collapsing with exclamation marks. So similar thing with intentions, but intention is when things are yellow. So just to show it, if I do this, it goes yellow. This is because this intention, it has build visitor thing, essentially is doing the same thing. It gets an expression, like a node in syntax tree, and then it checks if it's KT string expression and if text contains 2 exclamation marks. And then instead of returning, previously it was returning true or false, here it registers a problem, which is just reports there was a problem with some description. And it also registers basically a function like this class my quick fix, which is how you're going to fix this problem once you found it. And here it's doing a similar thing. It gets like the text of the exclamation mark, the text of the element, gets the exclamation marks replaced, and again, using PSI factory, creates a new element. So if I go back to this code, I can now like fix it with exclamation mark and replace with cat. So that's the inspections. Yeah, also highlights everything in this file now. And this is how you can basically do it. I'm not going to show, like, there is a more advanced example of how you can do nested references, but it's just like more details of the same thing. I'm sure like you can figure it out yourself if you try a bit and like play with syntax viewer and so on. And this was intentions and inspections. So this is what we looked at: intention, register intention, and inspection, which also unregisters them. I think there are, like, the whole thing is not super smooth. They definitely appear in the user interface. They also appear everywhere in IDE, as you can imagine. But I think like there are some problems that sometimes maybe editors keep references to this inspection, so it's like not super smooth. Also, PSI viewer is like, at least this plugin is a bit buggy. Maybe I should integrate something into LivePlugins to make the whole experience like working really well. That would be cool. And yeah, then I have this thoughts section, but I can show like a couple more things very quickly. So the other interesting thing why I think this can be useful, because like, for example, these lines, it's basically plugin on its own. So like there are a few other things you can do. You can get application. There are two ways to, like, this was more like proactive actions with IDE. There are a few other things when you can listen. IDE will tell you when something happens. One way is to have like extension areas and register extension. For example, this one is basically console input filter provider. So it's like a class which, like a factory for filters for console. So if I run this basically, oh, let's maybe go back to here. If I run this, it should print cat and exploding cat. This is the output. If I register this inspection, it will get the text, and let's say it will just show it. So that will be like the basic thing to just show it. So if I run main function again, it shows the cat over there. So it basically listens to the input, everything that appears on the console. But you can also do kind of filtering. The API is not ideal because it's like maybe never was designed to be easily used by people outside of like plugin development. So, but it all says if text contains content home bin Java, it's this line, then return an empty list, whatever that is. So if I run this now and I rerun this, the first line should disappear. So you see it just like swallows it. So this is how you can do console filtering. And it's like 10 lines of code. Why do you need more plugins, right? So you can just like have a plugin, write your own plugin, which will play a sound, or something like that. Yeah. And the other example is just really quick. I'll just show. You can do UI as well, obviously. So here, it's a bit like influenced by compose, I guess. It's like defining a panel, then there is a row. So if I run this, it registers this tool window with settings. Well, you'll see links, so I'll just skip it. Also, if I unload, tool window disappears, so it's all unloadable. And yeah, as thoughts, like closing session. So I think, well, the question I ask myself is like, if it's so cool, why is it not more widespread? Maybe there are some problems. And I think the problem is like chicken and egg problem, because plugin development is not easy, so not that many people try it. So IDE developers don't try to make it easy, and so nobody tries. So that's like a vicious circle. And maybe if there is like more demand maybe from users, like demanding better plugin development experience, or there is more interest, then IDE developers will be like genuinely motivated for good reason to make it all smoother and better, and then more people will join and everything will just get better. So maybe like if we get out of this like local minimum of everyone's happy with the status quo, maybe that's a good thing. To be clear, also there are lots of problems. Just to mention some, reloading plugin state can be very tricky, because here what I was showing, they were kind of stateless plugins really. But if you have like an object, next time you load plugin, it will be in a different class loader. And these classes, even if like the signature is identical, they're different, they're not compatible. JVM will not load them because they are, all the classes are scoped by class loaders as well. So maybe then you need to serialize, deserialize, which is like a separate problem, unsolved, basically. So it's solvable, it's just difficult. Then, obviously, IDEs, API, like you can use anything from LivePlugin, but they're not always designed to be like understandable, discoverable, or even easy to use. So yeah, that's a big problem. And then it's like hard to refactor because some plugins already are using these APIs. And then there is a question, of course, of like how do you even know where to start from the like empty screen, which is a difficult problem. Here with LivePlugin, I didn't mention, I guess the idea for me was, and I can improve it, just that you just type LivePlugin dot, and then you can autocomplete from there to subset of what can be useful. And another interesting idea is that, like, for example, if you take C++, there are like infinite amount of editors, and there is no convergence whatsoever. So there is like not a chance of people agreeing on toolset. For Kotlin, it's actually like basically JetBrains-based IDEs. There is Fleet, but I think the back end of the Fleet is still the same API from IntelliJ. So I think it's all really just compatible. So why wouldn't it be a cultural norm if you like write a library, you also write a plugin for IDE? That would be cool if it happens, and then just basically our experience as developers will be better, hopefully. Yeah, so links, it's just everything you've seen, it's in this repository. It's got like easy ways to create plugins. I also wrote this blog post, which is kind of the same content, but in written form and well, less content. You've seen more than that. And obviously, LivePlugins on GitHub, it's open source. It's a bit experimental, so it's not the best code base, but I'm trying to make it better. And yeah, any feedback is welcome. And this is it. Thank you.